Welcome to this PS2 Skill Gap Bridge course. As you know, this purpose of this course is to orient you towards the requirement of the work what you are going to do in the upcoming semester in the PS2 organizations. Okay, so computer organization and architecture is a very important course, and the technical aspects of this course are very much useful in the organizations where you are going to work. Okay, myself Brajabandu Mishra, and there is another faculty, Professor Gannon. We will be conducting this course. So I'll just orient you towards the course. Then we'll probably point to the recorded lectures which are there, which can be useful for you, and you should go through all the recorded lectures at that. Okay. So what is the objective of this course? As I explained, you need to be aware of the concepts of computer architecture in order to do the work which are there in the PS2 organizations where you are going to work with. Okay, so I believe all of you are from CS and ECE background, or EE or EEE background, I would say, or E and I, means all electronics and computer science background. And this particular course is very much useful for the organizations where the work is related to the architecture, design, verification and validation of VLSI. Also for the organizations where there are design, development and testing of embedded systems. Essentially these organizations, if you see, these are the organizations where there will be SOC design, and since SOC is being designed, uh, the corresponding low level software, that means a driver and little the software layer which is just above the driver and operating system, the work happens in that layer. So for all this work, the knowledge of computer architecture is very essential. So as we have seen in our past, the organizations expect the student to be aware of this concept before getting into the work. So that is the purpose why we are orienting you towards these particular concepts. Okay, so going to the next slide. This course is a, I can say it is a short course, and it is divided into 8 primary modules. The first module is related to the motivation of the course. Basically what now just I am trying to orient you, and you'll go through one recorded lecture followed by this one. And next one is related to the structure of CPUs and the performance measurement. Third one is related to the memory organizations. Fourth module is related to the input output. Fifth one is the little bit advanced concept, that is CISC versus RISC. Probably you would have seen till M4, that is till input output organization, you would have known all these things mostly in your microprocessor course. Whereas once you know about all these things, we need to understand about the advanced computer architecture concept, where this RISC come into picture. So from M5 onwards, these are more of a advanced concepts. So CISC versus RISC architecture, why should we go for RISC, and in what basically scenario we should go for RISC architecture. In fact, if you see nowadays in most of the embedded devices, the for example, say handheld device like a mobile phone or a television or a set-top box or a home theater system, RISC processors are more preferred. Okay, so but you cannot say that you can use CISC also, you can use RISC also. In fact, Intel Atom is used, there are so many places, whereas at the same time Qualcomm Snapdragon is used in so many places. So there is no hard and fast rule, depending upon where you want to use, what you want to select accordingly. So you must know about the CISC and RISC architecture, and next you must know about the pipeline architecture, which will be covered in module 6. In module 7, we'll talk about multiprocessor system, which is quite prominent nowadays. Whatever device you take, there will be either there are multiprocessors or there are multiple cores in the same processor. So multiprocessor system and multi-core system, more or less the architecture wise they are handled in the same way. Of course there are differences, so you will get to know about it. And the last module is related to ARM processor, which is why we are talking about ARM processor here, because this is one of the most popular processor core which are used in the embedded world. Okay, so probably in the organization where we are going to work, there is a chance, there is a, in fact, high probability that you may come across the ARM processor. That's why you should also know about the ARM processor architecture. So at the beginning, that is as part of model 1, essentially will give a general overview of the computer architecture, and from module 2 onwards you will get into in details about each of the computer architecture concepts. Okay, these are some of the textbook and reference book. Probably if you want, you can buy them, they will definitely help you out. And maybe in for some courses you may have these books. So the important books are like Stanning and William, Computer Organization Architecture, then by C. Hamser, Z. Varansik and S. Zaki, that is Computer Organization, and Computer Organization and Design by Hensi Patterson, which is one of the very important book. Then Essential of Computer Organization and Architecture by Linda Null and Julia Leber, and Jones and Barrett Publishers. Then last one is the Steve Forward. It is specifically related to ARM architecture. Okay, so please try to have this book and refer to these books whenever required. Some of these books may be useful during your work as well. Okay, so with this, I would like you to proceed to the next recorded lecture and complete the course. Um, if there are any doubt, any question, any help you need, definitely you can get back to either me or Professor Gannon through Takshila. You can ask us question, you can send us mail. We'll try to help you out wherever you require. So I would like to wish you all the best for your PS2, and we hope you will excel in your PS2 semester and impress the organization where you are going in. Okay, so see you till I would say when you want to ask a question, we'll be there always to help you out.